Today I'm going to talk a little bit about mobile phone data and what kind of data mobile phone operators record, and also why they're recording it. It's not sinister. It's actually got some really good reasons, and it's got a couple of really good things that you might not necessarily think of at first glance. We probably start with what mobile phone data actually is and how it's being collected and what is actually being collected. So the most important thing is with any kind of event, so we call these network events, is we record a time. So this is day, month, year, and the time of day. And then they record an ID for the handset that is coming from. So this will be your mobile phone. So this ID is not in plain text, so no one actually knows that's you, but rather the ID is being hashed. So it's just an anonymized ID essentially. And it also records an identifier for the cell phone, so the cell tower dish that actually serviced your call or your SMS or other event. So in general, it's the time, it's the identifier for your handset, and the location. Now, there's a number of other things being collected, but they're mainly of interest to the operator itself. So this is something like how much did this phone call cost, for example, what account should they charge it to? So is that something that was included in your contract? Is that something that was not included in your contract and has to be taken off your balance in the case of pay-as-you-go? Or is that something that has to be stuck on at the end and then you see an extra charge on your bill? There's also things like what country code did you call from? Were you someone from overseas who's visiting here, so we know, okay, they need to charge this back to your network operator in the other country. And that's basically the most important things that are being collected. So they never collect any information of what is actually inside your event. So let's say you send an SMS, they might know how many characters your SMS were, but they never know what the content of the SMS itself was. Generally, network operators differentiate between what's called active events and passive events. Now, active events are things that you actually do. So this is you send an SMS, you make a phone call or receive a phone call, you browse the internet, you move from what's called a location area to another one. Now, with a location area, you've got multiple cell towers in various places. And then some of these cell towers are grouped together into what's called a location area. And if you move from one location area to another, so let's say you go from here all the way over here, they would know when you cross this boundary here, and they would basically make a notice of you crossed that boundary. Then they also recorded if you switch between 2G, 3G, and 4G. And in terms of passive events, there is a ping that's being sent out every couple of hours. So let's say your phone is being stationary somewhere, you're not using it, you're not doing anything for 3 hours, it would then ping and basically say, oh, that person is still active, that phone is still a thing. And that's the general events that are being recorded. Now, the time between them varies. So if you think about how many times you're sending an SMS, how many times you're making a phone call, compared to what you did 10 years ago, that's probably a lower number right now. Whereas if you think about how much you're using the mobile internet now compared to about 3 or 4 years ago, that number is probably much, much higher. And that number is also increased with the amount of smartphones that we've got in general circulation.
So we're talking about all kinds of phones here. So what makes this a computer science question then?
So one of the things we're talking about it is because there's a huge amount of data that's being generated, and there's quite a huge interest in data science right now in the computer science community and also in the wider community. And it also has a lot of application areas beyond traditional computer science and analyzing what's happening in the network, to fields like epidemiology, to fields like urban planning, transport planning, to finance, and a lot of other fields where that data can generate huge insights. So epidemiology is this study of the spread of diseases. So one thing people might be interested in is trying to predict where diseases are going to spread next. So this was used quite extensively in Africa when we had the recent Ebola crisis, all the way to the recent Zika virus and various other diseases, where network operators have been working with local authorities and international organizations to try and identify areas that are going to be prone to the spread of diseases, or also identify communities that may be at risk of contracting diseases or infected communities, and trying to identify where that disease might spread next.
Warning bells clacks in the kind of clickbait question I'm about to ask there. We've seen large organisations be hacked. Should we be worried that all of this data about us is being collected?
No, we should not be worried. So a lot of organizations, and by organizations I mean mobile phone operators, when they collect the data, it's being anonymized before it actually reaches their systems to some extent. And what they internally work with is also already anonymized. So no one actually gets to see the raw data itself.
What sorts of things are happening with this data then? So you mentioned collecting it for various different things. I mean, what's your experience of doing things?
So personally, I've done a lot of work around tracking activity-based land use and tracking transport demand. So transport demand is you're trying to figure out how many people are going from A to B, how many people are going from B to A, how many people are going from C to D, etc. So this gives you a really quick overview of wider transport patterns in a city. So this is, let's say you want to see how many people are going from London to Manchester, how many people from Manchester to London, etc. So you can try and figure out where you want to maybe build the next rail line or where you maybe want to build a new motorway. Whereas the activity-based land use is looking at a city itself and is focusing on identifying where people work, where we've got residential areas, where we've got commercial areas, and how all these different things fit together and how cities evolve over time.
Is there enough information in, say, collaborating with one network operator to make this viable, or do you need to work with lots and lots of different providers?
Now, that is a tricky one, and you kind of hit the nail on the head. So one of the problems is, and this is something that's not just inherent to analyzing mobile phone data, but also part of any observational study you do, you get some kind of bias because you always only get a snapshot of what is actually happening. So we are trying to accommodate for the fact that one network operator doesn't generally cover the entire network and represent the entire population by using what's called an expansion factor. So you try and figure out different ways to come up with an expansion factor. So one way is, for example, in the UK, you might look at a particular area where you identify, let's say, 100 people as having their most frequently visited location during the night there, which is their home. And then you say, okay, we look at the census population and we look at the homes that we identify, we divide that and that gives us the scale factor. And we use that scale factor or expansion factor throughout to adjust all of the journeys they're doing. And that gives us like a slight approximation of what you would see in a national traveler survey. And there's various other methods, but that's one of the most commonly used ones, particularly in an area where you actually got census information available.
When you talk about something in kind of those generic terms of their most occupied nighttime location, that feels like that would be a way to identify someone from their phone, just because you could see where they lived. Is that, am I?
Yeah, sort of. So the thing to bear in mind there is, if you, let's say you look at a cell tower, and you have the coverage area of that cell tower. So traditionally with GPS, you could say, okay, a person is here, a person is here, a person is here, a person is here. So you know their home location is probably somewhere inside that circle. But with a cell tower, you just know they're connected to a tower, which can have a radius of a couple hundred meters. It can be, particularly if you're in rural areas, so if you're outside large cities, they can be a couple of kilometers apart. And you just know their home location is somewhere inside that couple 100-meter radius. Or because the cell towers are next to each other and their coverage areas overlap, it's like you can be anywhere along this circle here. Now you could potentially be in the middle. Generally that middle also tends to be a couple 100 meters apart, and it becomes really difficult. And especially as we move more towards living in high-rise houses, it becomes really difficult to discern where people actually are.
So sometimes your floppies would die, so you often would make backup copies. Let's try this one. Sounds more hopeful. And so there was this game called Lander, which became the full game Zarch. And when this game was released, it was sort of full 3D graphics, which